notation help. There is it's interesting. This was, I mean, this page that we're looking at right now is part of your notes, so you should be able to go in and take a look at it. This means right here, first derivative. And this right here means second derivative. Exactly. So it's asking at which of the following points are both the first derivative and second derivative positive. So what you could do is first is shade where's the first derivative positive. What does it mean for the first derivative to be positive? What's going on with the function? Yeah, Sarah.
That it's like increasing.
It's increasing, not like it is increasing. Where is the function increasing? So it looks like it's increasing halfway between A and B all the way to D. So then you want to label where is the second derivative positive. What did I tell you in class last week? That thing like, if the second derivative is positive, you're happy, you're smiling, so it's going to be concave up. So where is it concave up? Where is it concave up? It looks like it's concave up from here all the way to halfway through. Not all the way to D because it changes the concave down right there. No, it's not labeled there actually. It looks like it changes concavity like right here. That's where it looks like it changes concavity right there. So where are they both positive? What's the only point where they're both positive? B is the only place. Does that make sense now? Yeah. One thing that is, to be totally fair, you are absolutely right. The notation for calculus can be kind of annoying because there's going to be a lot of different ways to notate the same thing. There are many other ways to notate derivative, actually. Yes?
Would you ever do something like that on a 10?
Positive. And what about concave down? Here, right? So that means F double prime is negative, right? So look at A, for example. At A, you see point A right there, Sarah? What's the first derivative at A?
It's 0.
F prime is 0. But what's F double prime? No. Positive. It's positive again. What is the concavity right here? What is the concavity? It's up. So what's the second derivative? Positive. The first derivative is 0 at that point, but the second derivative is positive at that point. That's what it's talking about. So then over here, for example, then you can just, you just fill in each point. So that's A right there. So then you do all the rest. You do all the rest. Does that make sense? So I like making the color coding, and then I can just look at it and know what it is. So what's the derivative at B?
0.
F prime here is 0. What's the second derivative? What's the second? It's negative because it's concave down. And is the function positive or negative there? B is the function itself. It's above the x-axis, so it's going to be greater than what? Greater than 0. Exactly. What about C? Let's talk about C. F is it greater than 0 or less than 0 or equal to 0? Greater than 0. Is that concave? Is it rising or falling right there? So it's the first derivative is negative, and is it concave up or concave down? Down. So it's like that. So you just do each one like that. Does that make sense now? So I understand what you're saying. You're saying, how is it possible for something to have a first derivative of 0 but second derivative not 0? Well, it can happen quite frequently, actually. Absolutely. X equals 1, or x equals, what is that, 5? Yes. X equals 5. And then it says, approximate where g of x is least. Again, you're doing this on the domain here. You're doing this on the domain. What's going on here? It's falling, 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 and then what happens here? It's negative derivative, so it's falling, and then it's what? Rising, right? Negative derivative means it's falling, going down, and then it's rising. So this is going down and then up. And then this is going up and then down. So your choices for lowest point are either going to be here or here. Here or there, but here's the thing, which one's it going to be? -4, because how much has it gone up here? A whole bunch, right? So it's really low, it goes higher, it goes down a little bit, higher, so here, x equals -4. So how do you figure out where g double prime is 0? Where the derivative of this is the derivative, right? So where's the derivative of this 0? Here, here, and here. So what is that? It's like, I don't know, -2.5, 2, and 4? 4.1, yeah.
What if for
Yeah.
B you said, like, that you can't see how...
So what's happening when the derivative is positive? What's the function doing? It's increasing. So we know the function is increasing there and there. What about in between? What's the derivative here? The derivative is? It's decreasing. So this is decreasing. So if we're looking for a highest point, does that mean we're going for rising to falling or falling to rising. So highest point, we need to look for a place where it's going from rising to what? So highest point, rising to what? Falling. So where is that happening? Right here. So that's where it's going to, that's rising to falling. So the highest point, that's going to be when x is equal to what? -3. So lowest point, where's the lowest point going to happen? What's going to happen there? You're going to go from what to what? Falling to what? To rising. So where is it going from falling to rising? Right there. That's where it's going from falling to rising. So that's going to be x is equal to what? 2. Does that make sense? How are we feeling about that right there? Yeah, so 2x plus 1 is equal to 0, so 2x is equal to, so x is equal to. What kind of function is that? What is that? What kind of function is that? It's a line. Yes, it's a line. It's a linear function. Is the slope positive or negative? Yes, it's a function.
Well, isn't it like the vertical line test and points?
No, it's a function. This is a function.
Oh, yeah.
Yeah, that's what I'm asking. What is that? That's a line. So x equals -1. So what does 2x plus 1 look like if you graphed it? 2x plus 1, it's going to look something like this, right? And we just found, where does it cross the x-axis? What's that right there? -1/2, right? So to the right here, is it positive or negative to the right? It is positive, and what is it to the left? Negative. So what you can say is, does the concavity change here? Does the concavity change at x equals -1? The second derivative changes from negative to positive, so does the concavity change? Yes, it does. The concavity changes. So on this function, the original function, we don't have it. Have we graphed f of x? No. But we know that at x equals -1/2, what changes right there? It goes from concave down to concave up. So at this point, at x equals -1/2, the concavity changes from negative to what? To positive. So is this an inflection point? Yes. This is an inflection. We know an inflection point happens at x equals -1/2. The interesting thing is the number -1/2 by itself, is that a point? No. What do you need? A y value. But what's the challenge here? Do we know what f of x is? Do we have an f of x function? No, we don't. So we actually can't find the point right now. We can't. We can't. But we know that there's an inflection there. Now here's the thing. Is it possible to just touch 0 and come back up? So for example, let's say we graph the second derivative, and the second derivative did this at -1/2. Let's say it touched there. Let's say that was -1/2. The second derivative would therefore be, is it positive right there? Is it positive right here? Is the concavity changing? The concavity isn't changing, so therefore is it an inflection point? No. So you could say, no, it isn't an inflection point. You're looking for where the concavity changes. So it either goes from positive to negative or negative to positive. That's really important. That's super important. This isn't the line. We're not trying to find the concavity of this line. This is the second derivative. So we're using this to find out where the concavity changes. This is not the function. This is the second derivative, right? So I'm not saying the concavity is positive. The concavity is of this. No, this is telling us about the concavity of not the derivative, the function itself. This is telling us about it. So everybody, make your own groups, get up to the board, let's make calculus. And you're like in any calculus class, and this is only like 50% a joke. If you're totally lost on a calculus question, you literally have nothing to do, here's what you do. Take the derivative of the function and set it equal to 0 and solve. What you just did, okay, you took the derivative, you set it equal to 0, and you solved, and you got -2/3 and 2. You're going to do that literally hundreds of times in this class. Literally, not the new like teenage definition of literally, which doesn't mean literally, it means the opposite of literally. I actually mean it. You're going to do that hundreds and hundreds of times. And that's actually, I'm telling you the truth. You know about